channel. So in today's video we'll be finishing off with the basics of calculus. We did limits, we explained the definition of limits. So in today's video we will be looking at some examples of the limits and the types of limits that you are most likely to encounter on your exams. Now the methods that I'll be showing you are very useful and can be used to compute some limits, right? Okay, so let us look at some example. Let's say find the limit of the following, right? Of the following. Now find the limit of the following one. Let's say find the limit as x approaches 0 of the function 3 minus 2x squared, right? Go ahead and pause the video and try this on your own. So here you're basically going to have, well, remember that this here we will have what do you call this, we'll basically substitute the 0 in place of 3, so it would be 3 negative 2 times 0 raised to the power 2. Well, that's the same as 3 minus 0, which is 3, and then 3 squared is equal to 9. So meaning the limit as x approaches 0 of the function 3 minus 2x squared is equal to 9, right? So just to see things through here, let us plug this on our calculator and see what happens. So let us take a number very close to 0 and substitute it into the function and see what value that we get. Well, I'm gonna say, well, in the brackets, so let us say 0 comma a number very close to 0 is 0 comma 0 0 0 0 0 1, right? I'm gonna say equal to, and then I'll say, well, 3 minus 2 times the answer, and then that squared. We should get a number that approximates to 9, right? As you can see, we get 8,99999. That value approximates to 9, right? So meaning the limit as x approaches 0, then our function tends to be 9, right? Okay, so let's look at another example. Let's look at example 2. Let's say we have the limit as x approaches 2 of the function 1 over x plus 1 raised to the power x. Go ahead and try this on your own. So you can pause the video and try this on your own. So here we'll have, well, 1 over 2 plus 2, or rather plus 1 raised to the power 2, which is equal to 1 over 3 raised to the power 2, which is the same as 1 over 9, right? I hope this makes sense. So basically finding the limit is basically the easiest thing on calculus, right? So you're basically substituting the 2 in place of x, right? Substituting the 2 in place of x, and then yeah, you just get your answer. Then just put it in a calculator, then you get your answer. As easy as that, guys. It is not that complicated, right? So let's look at number 3. Let's look at another example. Let's say we have the limit as x approaches 5 of 2x squared minus 3x plus 4. Well, this is the same as the limit as x approaches 5 2x squared minus the limit as x approaches 5 of 3x, and then plus the limit as x approaches 5 of the limit 4. Well, this here we do not have to do this whole step here. You can just do it direct substitution, right? you can just do direct substitution, so meaning I could just say 2 5 squared minus 3 5 and then plus 4, right? So that's 25 times 2, that's 50, and then 3 times 3 times 5, that's 15, plus 4, and then we will get 60, right? And then 5 plus 4, that's 69, right? You should get a value of 69 in that case. So here similarly we will get the same answer. Well, this is 2. If you plug in 5, that's squared, minus, if you plug in 3, well, that's 3, 5, plug in 5 in place of x. Then here, well, our x here is the same as x to the power 0, so meaning if I plug in 5, 0, I'll get 1, meaning 1 times 4, that's 4, right? And then I'll get the same value, 69. So it doesn't matter which way you want to do it. You can do the direct substitution, or you can apply the laws of limit. It doesn't matter, right? It does not matter, but of course the direct substitution is the easiest, so you can apply the direct substitution. You do not have to show the whole step, right? Okay, so when we're dealing with limits, remember that we have some stages, or rather, let us look at some rational functions, right? So by rational function, I mean when we have fx divided by g of x, right? Fx divided by g of x. So we want to find the limit of this function here, right? So this should be familiar, right? When we are dealing with factorization and all that, right? So make sure that you are able to factorize. You are able to factorize. You know your factorization. Okay. So first of all, let us look at stage number 1, right? Now let's find the limit as x approaches, let's say a, of the function fx of gx, where fx is equal to, or rather in that case it is not equal to 0, and gx as well, it is not equal to 0, right? Let us see what happens. So let's look at some examples. So let's say the limit as x approaches 0, right, of the function x cube minus plus 2x squared minus 1 all divided by 5 minus 3x, right? Go ahead and try this on your own and see what answer you get. So basically you just substitute. We do direct substitution. You don't have to apply the laws. So you're going to be 0 cubed plus 2 times 0 squared minus 1 divided by 5 minus 3 times 0. So in this case I have negative 1 divided by 5. You can plug this on a calculator. You should get a value of 1 over 5, right? That's my limit. So so this is my first stage here, when the top part, or the numerator, it is not equal to 0, and the denominator is also not equal to 0, right? So you basically do the direct substitution in that case, right? Now let us look at what happens when fx is equal to 0, but g of x, it is not equal to 0, right? Let's look at that. So let's say the limit as x approaches, let's say 1, of x squared minus 3x plus 2 all divided by x plus 1. Try this on your own and see whether you will get the answer that you get, right? So by doing the direct substitution, well, this is 1 squared minus 3 times 1, and then plus 2 all divided by 1 plus 1, while this here, so 1, this will give us 1, then 1 plus 2, that's 2, 2 minus 3, that's 0, then divided by 2, well, 0 divided by 2, well, that's 0. So you can see if like you plug this on a calculator, here's my calculator. Let's look at this. Okay, so I'm gonna take the number that is very close. I'm gonna take the number that is very close to 1. I'm gonna take the number very close to 1. So let's say 0,9999999. I'm gonna say equal to, and then I'll just divide. Then I'll say answer squared minus. You can take any value that is close to 1, right? And then times 3 times answer, and then plus 2 divided by the answer plus 1. So the value that we get, it should be approximately 0, right? It should approximate to 0. You can see that this value here is very close to 0, so meaning the limit as x approaches 1 of this function here is equal to 0, right? I hope that makes sense. And then the other one will be, let's say fx is not equal to 0, but in that case gx is equal to 0, right? Gx is equal to 0. So what happens then? Well, let us see. So let's say you have the limit as x approaches 0. Let's say 1. One of the function, let's take the same function on top, x squared minus 3x plus 2, and then here we're going to change the signs, say -1. Well, go ahead and substitute this, substitute the 1. So you have 1 squared minus, rather to give us negative, let's put a positive there. Let's say plus 3 times 1, then plus 2, then all divided by 1 minus 1. So on top I'll have, well, 1 plus 2, that's 3, 3 plus 3, that's 6, all divided by 0. Now 6 divided by 0, that is a math error. So in your calculator you should get a math error. So what does that mean? Basically, what does that mean? Well, to us this means that the limit does not exist, right? That means that the limit does not exist. Let me show you how. So I'm gonna take that very number. Come on. Okay, so I'm gonna take this calculator though. So I'm gonna take that very same number, right? I'm gonna take that very same number. Let's say a number very close to 1. Let's say 0,99999. This number is very close to 1. Say equal to, right? Now say division, and then I'll say, well, answer there squared plus 3 times answer plus 2, all divided by answer minus 1. So here you can see that we get that number. It's very scary. So you get -5,999,999,5, right? 95, I think. 995. You get that number, right? So you can see the number that we plugged in there. It's a number very close to 9. I'm very close to 1. Let us check another number very close to 1. Let's say 0,9. Let's say 0.9. So 0.9 is a number very close to 9 also. Let us see. So if you say, well, the same number squared and then plus 3 times answer and then plus 2 divided by the answer minus 1, well, now you can see we're getting a very small number, right? So you're getting 59,9, and then if I plug in another number very close to 1, 0,999, then if I plug that on my calculator, well, I have answer squared plus 3 times the answer and then plus 2 and then answer minus 1. Well, now I'm getting 95.99. What is happening here, right? So all these numbers, they do not correlate. This one is bigger, way bigger than this one. This one is way bigger than this one. So what is happening, right? So this means that the limit does not exist, because we are getting all these numbers that do not make sense. But 0.999999 is approximately 0.99, which is approximately 0.99. 0.9. So we should approximately get the same values, right? Not the other way around. So in this case, we are getting a very, very small number. Here we're getting a very big number. Here a semi big number. What is happening? That means that the limit does not exist, right? So, and hence why when we're getting this here, we say the limit does not exist because of this here, because of this thing here happening here, right? The other value is giving us a very small number, the other one is giving us a big number. These numbers are not even close to each other. So please take note of that. That when we say the limit does not exist. Okay, I hope that makes sense. And then on our next video, we'll be looking at when both g of x is equal to 0 and when fx of course is equal to 0. What happens then? That is when we use our knowledge of factorization, rationalizing, and all other techniques to find the limits, right? So for now, let us stick to this one here. Let us do this one here. So I hope these make sense, right? All the limits, these are easy limits, basically substituting or rather putting the 0 in place of 3, right? So in order for you to like, most people will be asking me, like, how do you know whether you need to factorize or not to factorize, or just do direct substitution? Well, you're gonna look at that on our next video, right? Because for that one there, whether you want to if you want to know whether you should factorize or not, then when you substitute your value into the function, then you should get the 0, you should get 0 on top and 0 at the bottom, which in this case is what we're going to look at on our next video. So this is what we call the indeterminate form, right? This is what we call the indeterminate form. You will look at it on our next video, but for now, just look at the limits, the easy ones. This one is just basically substituting the value of x, or rather you're just substituting this value here in place of x, right? In place of x. So here we notice that we do not have to factorize. We don't have to factorize. Why? Because this top part is not equal to 0. So meaning there's nothing in common between these two. There's no common factor between these two here, right? So meaning we do not have to factorize, right? Rather, even if you factorize, nothing will cross cancel. So in that case, that means the limit does not exist, right? You only factorize when you get something in this form here, which we'll look at it on our next video. So I'll catch you.